So, hello everyone, and welcome to this weekly session, Ask AuxEn Anything, that we conduct. And as you know, that this is an online platform for civil structural engineers to interact with us and ask their queries or doubts that they may have related to RCC steel design project that they are doing, or any uh, concept related to RCC steel design, or construction site issues. And this is the 55th such episode that we are conducting. And let us begin by taking the queries that have been asked for this week. So take the queries from first I'll take the queries from the Google form, and then we will go to the queries that have been put in the live chat. All right. So let me just see what has happened. Just give me a minute. There used to be this background every time that I'm not able to see. Yeah, this background we used to we have every time, right? This I was not able to see earlier. Okay, what else I need to do? I think this looks good. So let us begin by taking the queries. And first query is from engineer Naveen MG. He is from Bengaluru, and he is a postgraduate student and a working professional. So he's asking, designing the while designing the combined piled raft foundation, how much percentage of load will be taken by piles and how much will be taken by raft, and how to design? Can you please give some basic ideas? So this topic we have covered in great detail in our course on foundation design, where we have dealt with the issue of raft foundations, and then we have also taken up the case of pile draft, where you combine two structural systems, uh, which are the raft foundations and piles together. Now the uh, load transfer will depend on number of factors. So for example, if I were to draw a cross sectional view, and let's say orange is the raft thickness, and then there are piles over here. So now, because two different systems are involved, the percentage of load taken by piles and percentage taken by raft will depend on, first of all, the soil stiffness, or let's say the subgrade modulus below the raft. Okay, so what is the type of soil and what is the subgrade modulus it can offer? So let's say these are the spring constant of your soil below the raft. So number one is that, with compared it with the spring stiffness that is offered by piles. So spring stiffness of pile. So this is also uh, sort of a subgrade modulus, but we don't use the word subgrade modulus because we generally use the term subgrade modulus for areas, and over here it's a pile, so I'll use the word spring stiffness, let's say, or stiffness of pile. So depending on the relative stiffness between the relative stiffness between the subgrade modulus below the raft and the spring stiffness of the pile, the percentages of loads being taken by raft and percentage of load being taken by pile will vary. So you can find that out. We have done this type of an experimentation in the foundation design course. So for example, you had applied certain load intensity. I'm just taking some value, arbitrary value right now. So let's say if there's a 100 kilonewton per meter square uh, pressure that is acting, okay, or load acting on your raft, then you can easily find out that what is the bearing pressure below the raft. Okay, so this will be the bearing pressure below raft, and you can find out how much pile is taking. Then you can multiply the bearing pressure that raft is taking into area of raft, so you will get how much load is being taken by raft, and subtract it from the total load acting, 100 kilonewton per meter square into area of the top portion of the raft, let's say. So you will have the total load, out of which you know how much raft is taking, so the balance piles are taking. And then you can try to vary the subgrade modulus of soil and or the pile spring stiffness, and you will see that the load distribution also changes. So basically the percentage will depend on your conditions, that how much in your case, what is the subgrade modulus of the soil and what is the pile spring stiffness. It will also vary on the pile spacing that you have adopted. So whatever spacing of piles you have adopted, that will also be an important aspect in figuring out that how much percentage of load is being resisted by piles and how much of it is being resisted by rafts. So these issues will determine what is the percentage distribution between the two systems. Mr. Suraj Nair is asking for K value 2.5 factor of safety is required to be applied or not. So we have discussed this issue number of times before, that this K value that you get, it is the stiffness, so it is the load upon settlement. Okay. Now if you are taking ultimate load, let's say you are multiplying 2.5 into the let's say if you are multiplying 2.5 into SBC, dividing it by settlement, getting some K value, you are not supposed to stop at this K value. You have to apply it and then check the bearing pressure that you are getting and the actual settlement that you are getting. Okay, so if the bearing pressure and settlements are not similar to what you had assumed initially, you will again need to do the iteration. So the basic thing is, whatever value you may start with, let's say you start with 2.5 times into safe bearing capacity of soil divided by the expected settlement at that value. Okay, and you start with this let's say you have started with the ultimate level, so you have multiplied it by 2.5. Then you get a K, you apply that K, you run the analysis, you get the values results. Then you again have to check what is the actual settlement that you are getting and what is the bearing pressure that you are getting below your raft, let's say in this case. If those are not matching with your assumed results, then you go back and change the K value, again apply the new K value, again run the analysis. So this has to go on until convergence is achieved. So what I'm trying to tell you, that whatever you may be your starting point, some people start with, let's say, SBC upon delta. You may start with 2.5 into SBC upon delta. You need to reiterate and then you will reach the same final value. Understood? So this 2.5 is not required. You just start with SBC upon delta, and then whatever you get, whatever bearing pressure you get, and whatever settlement you are getting, accordingly reiterate, change the K value, take the new K, apply it again, and run your analysis again. Okay? All right. So this was first query and some related queries on this issue. Then we move on to next question. So next question is from Engineer Chandra. He is a working professional from Vizag, Visakhapatnam, and he has couple of queries, not couple of queries, three queries. So he is asking when does and why the buildings collapse or majorly damaged even after perfectly designed. Are you talking in terms of earthquakes, or are you asking that under earthquake event, why do buildings collapse or why are buildings getting damaged, or are you asking for normal uh, gravity loads? Mr. Naveen MG is adding to his earlier query, in convention engineering, the people tell that whatever the case, pile should take 70% of load. No, no. As I explained, see, it's not about how much it should take. It's not about it should take. You may desire that I want, because you are wanting to provide piles, okay? Because you have decided that you want to provide piles. So naturally, if you are providing piles, and because pile is a more efficient system than a raft, so if you are providing piles, you may naturally want that piles should be carrying majority of the loads. That should be, or that might be your design intention. Understood? So since you want to provide piles, it might be your design intention to use or to have the maximum efficiency that you can get from the pile system. So you may desire that you want, in your design, you may wish to have at least 70%, as you are saying, that at least 70% your pile should take. If that is your desire, then accordingly you need to ensure that the pile spacing is provided in a specific manner. Okay, you need to also check what is the strata, and for that strata, what is the load settlement curve of the pile. From that, you need to calculate the pile stiffness. You also need to check that at the level where you are going to provide raft, what is the subgrade modulus that will be offered by soil. Put that value also, then see what percentage of load distribution you are getting. Understood? So uh, it's not about convention. It's about your design intention, and because you are providing piles, you want more efficiency or more load carrying. uh, you may want that more load should be taken by piles, and for that, then you have to accordingly set up your spacings, as I just told, or you may have to accordingly choose your pile lengths, or you may have to choose the pile dia, so that you reach to your, let's say, 70% goal if you have. But as such, there is no percentage uh, guideline or percentage guidance given anywhere. All right, it may be your design wish. And some people tell, he is adding, and some people tell, when we design combined pile raft foundation, raft will just act as a pile cap. Again, the same answer, that it will again depend that at what level you are providing your raft. Okay, sometimes it may happen that you are not able to go very deep. All right, so let's say this was your ground level, and because of the restriction or because of whatever conditions you had, you're not able to go very deep, and you had to provide this kind of a raft, and then you had to provide your piles below it. Now, since you could not go very deep, the strata that you get at this level is not a very good strata, so you are not getting good enough or adequate subgrade modulus of soil at this level. So naturally, in this case, raft will not be able to resist much of the loads, because the subgrade modulus is not that high that you are getting. Okay, or let's put it this way, that the bearing capacity of the soil at this level is not quite great. So if that is the situation, then your raft will act only as a load transfer element, and your rafts will only transfer their loads to the piles. It may happen, but then there might be situations where you are already going, let's say you had two basements. Okay, just some hypothetical situation I'm taking. So you had two basements, because of which you are going to a certain depth, and over there the soil is also having a decent enough SBC bearing capacity, but then because it was not sufficient, you had to add piles. And at this level now, the SBC of soil at this level is significant, and it will that will mean that rafts will take significant loads, and the balance your piles can take. So it all depends on your structural configuration. Okay. Okay. All right. So now we come back to the question asked by engineer Chandra from Vishakhapatnam. He's asking, when does and why the buildings collapse or majorly damaged even after being perfectly designed? I'm not sure whether he is asking in terms of earthquake loads or whether he is asking for normal gravity loads or day-to-day service loads that your structure is expected to face. So if he is asking in terms of gravity loads only, the day-to-day dead load, live loads, and his question is why does and why the buildings collapse. So building collapse may have, I mean, I cannot pinpoint a particular reason. If your laws of physics are not managed, okay, the gravity is always trying to pull the structure down. So if your laws of physics are not managed, your structure has to fall down. All right. Your question should have been, why do poorly designed structures still stand? Anyway, so if you are asking in terms of gravity loads or for gravity loads, then as long as the laws of physics are managed or taken care of, although your design may look poor with respect to the codal provisions, but it still may stand. Structures don't fall down on small mistakes. Structures usually fall down when there are blunders made while in design or in construction execution or during the operation maintenance. Okay. If you are asking with respect to earthquake loads, then you must understand that that is our basic philosophy in earthquake design, that structure will undergo damages, although we don't want them to fall down because falling down is related to loss of life. But when we are designing for earthquake, in fact that is our design intention, that structures should undergo damages, because that is how the inelastic energy is going to be dissipated. So, and then it's a very thin line, that structure getting damaged, and finally due to the damages the structure may be falling down. It's a very thin line between that. So our earthquake philosophy, in fact, we desire structures to have damages, although no collapses, but then it's a very thin line, as I just said. uh, yeah, so that is my that those are my thoughts on your question. His next question is, suppose if we design a building for 5 magnitude, Richter scale 5 he is asking, and 9 magnitude earthquake happens, what happens to the building? So building is supposed to fall down, then it is it would be extremely rare that structure will survive, because remember, as I just told you, even if a 5 magnitude earthquake hits, chances are that your structure may still fall down. As I told you, because structures are mostly designed only for preventing vertical collapse, damages are still expected, and there's a very thin line between a damage happening and due to some unforeseen circumstances actual collapse happening. So even at same magnitude earthquake for what you had designed, let's say, it is still quite possible that structure does fall down. So if the magnitude is 9, that means energy is exponential. These Richter scales are not linear, so these are exponential. So from 5 to 9 means, if I remember correctly, 10 to the power 4 times more strong will be your earthquake energy. So the entire city will be wiped out. Forget about the structure. If a 9 Richter scale earthquake was to hit, expect the entire city to be wiped out. Okay, wiped out. Then his next query is, what is his next query? When consultancy firms design the building, what are the additional safety measures you consider making it completely safe? I would say design as per the provisions given in the code. Okay, so as long as you are following the codal provisions, uh, I think at least not collapse. I mean, collapse not happening is taken care of. And then, if structures are important, also ensure that whatever you are doing is executed in the same manner on site. Also, that is also important. So, if required, you may have to do some supervision uh, to ensure that whatever you have provided in your drawings and design is getting executed on the site also. And what else? So additional safety measures, I don't think we take any additional safety measures. With experience you may come to know that what are the pitfalls or what are the points where there might be issues, and then those become, let's say, non compromisable or non negotiable items. Okay, for which then you have to be very careful in design as well as in execution. For example, connection in steel structures are non-negotiable items. They have to be taken care of quite well. Otherwise, most of the steel structure failures happen at connection levels. Very rarely do they happen at the member level. Or to give you another example, uh, let's say beam stirrups are quite important, or the development length in your bars, especially the top bars in beams, is quite important. So that may be one of your non-negotiables. Okay, or non-negotiable means where, as engineer, you should where you should ensure that whatever you had designed is getting executed as it is on site, and there cannot be any compromises in that. So with experience, you get to know that for what type of structure, what item is very important. And sometimes you may have to take this practical viewpoint that some items you may make compromises, but for some items, it must be ensured that it is executed well on site. So I think these, I will not call them additional safety measures, but these can be some points that you can keep in mind while designing or while providing your design drawings. Okay, so these were the queries that were put on the Google form for this week. I'll also check if any query has been received on the email. So I think there is no query this week on the email. Yeah, no query on the email. So now we take the queries that have been put in the live chat. And where is our live chat? Yeah. So RGKK-T2I, I think is Mr. Raghu. He is asking, what are how should tree columns? What is tree column? How should tree columns be designed and detailed? Are these types of structural elements recommended, and can they be used in seismic zone 5? I think what he means by tree column is something like this in elevational views. Something like this. This is what he means by tree column. This is elevation where there is, let's say, main column, and then it is branching out in 1 and 2, and then there might be some structural system over here. So he is saying, is this how should be designed? So I think for design you need to first get the analysis outputs. So for that you may model it as line elements. Okay, model them as line elements in your software like etabs or stat. If you want to get proper joint stresses, or if you want to get proper joint forces, then you may model them as, let's say, wall elements also. So in ETABS you have good wall element modeling options, very easy to use. You may accordingly model them as wall elements. So from there you will get the proper stresses, moments, etc. at this junction. So I think in case of wall elements like this, the junction becomes important. And for detailing, you may not be able to continue the bar from the bottom to top in one piece, because then there are some requirements of the slope of the bar that you can maintain. So in, I think you're correct. What is this? Not a good drawing, but let me just see what I can do. Yeah, something like this. So you might not be able to take one bar, because then there are detailing restrictions that this bar slope cannot be steeper than 1 in 6. Okay, so this bar slope cannot be steeper than 1 in 6, so you may not be able to continue one bar. So detailing is important. Maybe you need to take this bar and beyond this face develop till a distance of LD for this bar. Then similarly you need to, for beyond this face, you need to maybe take it to the farther face. That is what we generally do in joints that are susceptible to opening, like we do in staircases also. So this type of arrangement you may have to make, and for that whatever detailing lengths are required, those items, I mean, you need to study well. Then for this junction shears and these items, I mean shears and concentrated stresses may be checked, and for that the stirrups have to be accordingly provided. So although I have not provided this type of a column anywhere in any of my projects till now, but these are some initial thoughts that I have uh, when it comes to your query. Whether it is, can it be used in seismic zone 5? So there is nothing that tells, I mean, nothing in the code that does not allow you from using such a column, but then you will have to be careful. But what you should be careful about, maybe don't run an equivalent static, run a response spectrum to get the full idea. Maybe you can additionally run the p delta analysis also in the software, just to see what is the effect of deformed geometry on your member forces in such cases. So I think these are some of the things you can take care of. Ductile detailing, maybe you can still follow all the rules that are given. So for this column, treat it as a other, I mean, treat this branch as a separate column. For this, whatever beams are framing into it, try to satisfy the beam column joint capacity ratio and the joint shear check. For this branch also try to satisfy the same. So I think for ductile detailing, you may like to follow all the provisions that are given in the code for a normal column. And for this junction, I mean, for this section also, whatever is the beam arrangement over here, accordingly check for joint shears, etc. So these are my initial thoughts on your query, although in none of the projects I have used such a column till now. All right, then Mr. Suraj Nayyar is asking how much loss of contact is allowed in the footings for industrial structures. There is a guideline in the code number I am forgetting. We have discussed that in the foundation design course. Let me see if I can quickly get the code number. Uh, is it? 1904. You may check in 1904. Although I'm not sure whether it's the same code number, but usually it says that not more than 50% loss of contact should be allowed. Not more than 50% loss of contact shall be allowed. I think IS 1904, you may check. But remember that this loss of contact also should not be, uh, this, if you are allowing 50% loss of contact, it should be only for cases where, let's say, wind or EQ loads are involved. Okay. So these are those, in combinations where EQ and wind are involved. So these are those load combinations where wind and EQ are there. That means they are probabilistic loads not acting for a very long time. So maybe for these load combinations you may allow up to 50%. But for the loads which are always going to act, in my opinion, you should not allow any loss of contact. Okay. So generally when we design footings, we do not allow any loss of contact for dead and live or gravity loads or loads which are always there, and for load combinations where you have got uh, probabilistic loads or short time load acting loads like wind and earthquake especially, there you may allow loss of contact up to 50%. But then also ensure that if your structure is quite critical, remember that 50% means that there is a certain rotation that is induced in the structure. So you need to check stability also. For that you should check the superstructure stability. In case you are allowing loss of contact up to 50%, that means this portion has lifted up, there will be increased pressure in this, so there is a certain rotation that is added to your structure. And for very critical or very long thin slender structures, you may additionally check the overall. Yeah. So I don't know if my voice is still audible. Is my voice audible? Right. So this was a query by Mr. Suraj, and let us take further questions. Yeah. So okay. So we are back to this. Let us take further queries then. So next query is from Engineer Ganesh Patil. He is asking, please explain how shear capacity is designed based on overstrength plastic hinge principles. What does mean overstrength plastic hinge principles? See, generally what happens in case of ductile design detailing, uh, because we want to dissipate the earthquake energy, we want, or rather we wish to have the earthquake energy dissipated through inelastic deformations, but those inelastic deformations shall not lead to overall collapse. So, in case of a beam column frame, if this is the elevation, this is the column above, this is the column below, this is your beam. In case of seismic event, I don't want wish to have any inelastic regions. By inelastic regions, I mean that a section where all the fibers have reached inelastic levels. That means the stress levels in all the fibers have gone beyond the Fy and they are into inelastic range. So I don't want any such zone to be created in the column, because if such a zone is created in the column, it may lead to vertical collapse. So in a beam column frame, typically I may want, or rather I desire to have such a zone in my beams. So for these beams, I call them as plastic hinges. Now, plastic hinge means that all the fibers in this section, if I were to look at this cross section of the beam, all the fibers of this cross section have gone beyond their yield level, and let's say the stress strain distribution, instead of like this, has become something like this, where all the fibers have reached a stress level more than or Fy. So this is the level where I call it as the, and then because all the fibers in my cross section have reached the plastic level, or sorry, because all the fibers in my cross section have reached the yield level, they are not offering any resistance to rotation. Yeah, because beyond yield in the post yield region there is no resistance offered to the rotation. So that's why we call them as a hinge location. Now what happens is that your material in fact does not stop at Fy. In fact, it continues to go up till what is called as Ry times Fy. Okay. So you are expecting in stress strain that your material will yield at Fy, but it continues to be more stressed. I mean, it continues to take in more stress levels even beyond Fy, and this is called as the overstrength of your material, and it happens due to some internal reorganization between the fibers of your material. So it's a material property. So there is this overstrength also. So you are expecting the cross section to yield at Fy, but in fact it reached Ry times Fy. That means that you are expecting a moment capacity being offered by this cross section to be some, let's say, mu based on material property Fy, but it reaches some Ry times mu mc, let's say mc. You are expecting your material, or you are expecting your cross section to have some moment capacity at a level mc corresponding to a stress level of Fy in the material, but in fact because of the overstrength, the section develops Ry times mc. So this is called as the overstrength effect. Now, because your cross section at this level, under the effect of EQ, where plastic hinges have developed, and this was desirable for us as per our ductile design detailing concepts, because these are the regions from where energy gets dissipated. So we wanted that some sections should reach their yield levels, but at even at this level, there should not be any shear failure. Why should not be there any shear failure? Because shear failures are brittle in nature. Shear failures are brittle in nature, so we do not want any shear failure to take place. This plastic hinge formation that I was talking about is more to do with the flexural loads. In flexure, my section is not brittle, it is ductile. That means it will give you enough warning before failure. While in shear, my section will have a brittle collapse or brittle failure. So even when there is a flexural plastic hinge formation in my beam, I don't want that beam should fail in shear even at this level. So what I do is I do not design for the shear loads due to gravity. In addition to this, I also add the excess shear or the additional shear that will be generated due to this plastic hinge formation and the uh, section capacity at this level. You understand? So that is the reason why I will just add up by simple mechanics. Let's say I'll add up the moment capacity being developed at these 2 points, let's say A and B, and then I divide it by the distance between them, let's say X. So this is the additional shear that gets generated or that may be generated due to this plastic hinge, and this I may add to gravity shear, and then I design my beam for this overall shear. So this in short is the capacity shear for which we design our beams mainly. In fact, we do columns also based on same principle, but it's important mainly for beams. So this is the principle that we use for design of beams, especially for this kind of a capacity shear. Okay, good. So then next question is from Shiva Chandran. No, Shiva Chandra. In case of pile cap designed with biaxial moment, instead of tie beams, can we provide plinth beam? Is the purpose solved? See, purpose you may provide, but it will be more effective. He is asking, his question is, let's say you had a, I am showing you the cross section, and this was your pile cap with piles, and you had at this level some tie beam, okay, and let's say this is the NGL level. I hope you are able to see the screen. This is, let's say, the NGL level. So near NGL you had this pile cap, then you had your pedestal, and you had your beam. This was your plinth level, let's say. So his question is that instead of providing tie beam at this level, what if I provide plinth beams? Will it be effective? It will be effective, but the efficiency is most when it is at the tie beam level. So this plinth beam, because it is connected to pedestal or column, and then this column is in turn connected to tie beam, pile cap. So the effectiveness of this plinth beam is naturally not as much as what you get from the tie beam. So my suggestion would be to have a tie at it, have a tie beam instead of, I mean, if you have biaxial movements in the pile cap, either you then go for a 4 pile or 3 pile configuration, and then you may avoid tie beams, or else introduce tie beam but then have it at right at the pile cap level. Only then it will be most effective. Okay. The next query is from engineer Arjun Srivastav. He is saying, if I have 4 cranes in a single box type shed, how many primary load cases I have to make and how much load I have to consider? 50 tons plus 50 tons plus 50 tons plus 30 tons. So it's a is it a single portal? What are your, let's say this is the plan of your shed. I'm not sure what box type shed means. I'm assuming it's a shed like this. So what is your, just give me some uh, shed dimension. Hello, if you are there. Okay, I think he's not there. Let's say these were your columns in plan. Now see how many load cases you need to make. That will all depend on, first of all, what is the nature of your crane operation. What is your column spacing? Let's say it is 7.5 as a standard spacing. I'm taking 7.5 meters, and the number of load cases will first of all depend on your crane operation. So in plan I'm showing you. So let's say this is 50-ton crane. Now sometimes what may happen is that these cranes also have a certain minimum distance that they have to keep in between them. Okay, because they, let's say this was your crane, then there will be some wheels over here. So let's say it's getting supported on your wheels like this. So this dimension itself is 3 meters, imagine. Okay, so now at the most, if this column to column spacing is 7.5, at the most not more than two cranes can be in one bay at the same time, isn't it? Not more than two cranes can be there in one bay at the same time. If this was, let's say, 3 meter and the column to column spacing was 7.5 meters. So although you had four cranes, 50 plus 50 plus 50 plus 30, but because of these dimensions you may not be able to fit in more than two cranes at a time in one bay. All right, so this might be one of your uh, things to consider when you are making load cases for different cranes. Another point you may have to consider is uh, the possibility of their working in tandem. So it happens sometimes that this 30-ton crane is just parked at the end, it's not in use, and 50-ton cranes are being used. So accordingly, your load cases may vary. It also happens sometimes that some cranes will only operate in some portion, okay, and some cranes will operate only in some portion. So that is also a thing which is quite regularly seen, that it's a 50 plus 50 operates in this portion only of the shed. In the next shed, next half, let's say 50 plus 30 were acting. So you need to take these inputs first, and then you may be able to decide. He's saying 10-meter bay and wheel to wheel distance is 4 meters. Okay, so 4 meters is his wheel to wheel, and then base spacing is 10. So at the most, let's say 50, 50, 4, 4, 8. Actually, there will be some clear distances also between the cranes. So maybe two full cranes, and for one crane, you may be able to fit in one of the wheels, maybe. All right, in 10 meters. So accordingly, first of all, you need to check for your crane girder. When it comes to the uh, impact loads, longitudinal and transverse, then you have to consider the possibility of your crab. So sometimes you may consider all three crabs are over here. In one case, take the lateral load for your design. Then you may also consider, let's say, one crab is here, two crabs are here. Accordingly, consider. Then one crab is here, one crab is here, one crab is in middle. Accordingly, consider. So all these types of different load cases you may have to make. How many numbers will be there? I cannot straight away say. You will have to sit down and come up with all the possibilities. Some of the possibilities may be repetitive, or you may figure out that this possibility is not so critical, so you may ignore that. Uh, let's say you may ignore that uh, option from your load cases. So accordingly, you need to sit down and come up with the various possibilities. But keep in mind these inputs that I have just given while deciding the number of load cases. Okay. All right. So these were the queries that were asked on the live chat. So we have taken up all the queries that were asked, that were put in the Google form. We have also taken the queries from the live chat. There was no query that was there in the email. So I think that's it for this session. If anyone has any further query, they may ask, or we close down today's session. Any further question? Okay, so that's all for this session then. You can continue to put your queries in the Google form. And as you know, once every week when we meet, we take up your queries. So Mr. Arjun is saying I have to use 4 loads at one bracket. What does that mean? 4 loads at one bracket. See, first you make the possible cases or possible loads, I mean, possible crane arrangements for your uh, gantry girder first. So see what are the different type of loads that may have to be taken by one gantry girder. First check that out. Then you see for bracket level. So as you are saying, for let's say for this bracket, there is a possibility that one 50-ton crane is over here, another 50-ton crane is over here, and right in the next bay there is another 50-ton crane very near. So all loads then get transferred to the bracket. So first you make all the possibilities for the gantry girder, then you check all the possibilities for the crane bracket, and then that's how you need to decide. Okay, so these were the gantry girder for 2 cranes. Yeah, 2 at least, possibly 3 also, because as you are saying 4 meters is the wheel to wheel distance. So 2 full cranes and even one half crane can come over there, isn't it? So 4 plus 4 8 plus one wheel can come on the two full cranes, 2 full loads of cranes, and let's say one crane with one wheel in between, I mean one wheel within the 10 meters, that also need to be considered. So two and a half. Okay, so you can continue to put your queries in the Google form that you already know, and once every week when we meet, we take up your queries. And if you want to connect with us on WhatsApp, you can click on this link to connect with us. So this is the link for WhatsApp. Where is it? Yeah. So you can click on this link and connect with us. So this is all what we have for this session. Then we'll meet you next weekend in another such episode. So that's all. Thank you and have a good week ahead, and see you. Bye bye.